In our second lesson of this unit, we will continue talking about function composition. That's where you're substituting one function back into another function. And we will also talk about other function operations, your addition, subtraction, multiplication, and some division. Alright, so looking at example number 1, if I want to add two functions together, it's very simple. It's often just a matter of combining like terms. Function f in this example is x squared. So there's function f. And then we're supposed to add that to function h. Alright, and function h is x plus 1. Okay, so here's function f plus function h. Now in this case, because there's nothing in front, not even a minus sign that needs to be distributed, I really didn't need the parentheses this time. And normally it would be a matter of combining like terms now. But there are no like terms. All these are different. So this is actually the final answer. So you would just go ahead and put x squared plus x plus 1, and that's it. Let's look at number 2. Function k. Alright, so that's x minus 3. And then we're supposed to multiply that times function h. Okay, which is x plus 1. Alright, now to multiply a binomial times a binomial, you know, some teachers teach this as the FOIL method, first, outer, inner, last. I usually look at it as simply doing the distributive property twice. So if you take x and do the distributive property, alright, I'm sort of temporarily ignoring the negative 3. In fact, let me just erase this so you can focus better. If I distribute this x, I'm going to get x squared plus x, because x times 1 is x. Now putting that negative 3 back in there, now I want to distribute the negative 3. Okay, if I distribute the negative 3, then that's going to give me negative 3x, and then negative 3 times 1 is negative 3. This time we do have some like terms to work with. The positive x and the negative 3x. If you put those together, that's going to give you negative 2x. So we're going to wind up with x squared minus 2x minus 3. Again, the negative 2x just came from combining these like terms. Alright, so that's some multiplication. Neither one of these have any domain restrictions. One of the most common domain restrictions involves having an x in the denominator. If I had some function that had an x in the denominator, x could not be 0. Alright, and we'd write this as a domain restriction. Okay, if we had something like x plus 3 in the denominator, now x could be 0 if it wants to be, because we'd still have a 3 there, and dividing by 3 is no problem. But this time we have a new domain restriction that x could not be negative 3. That would be my domain restriction, because if x was negative 3, then I'd have negative 3 plus 3, and that would make 0, and you cannot divide by 0. So anyway, so far none of these problems even had a denominator, so we didn't really have to worry about that kind of domain restriction. But keep your eyes open. I think it's coming. Anyway, let's look at number 3, subtraction. So we need a function k minus function g. So function k, again, is this x minus 3. Okay, so we will have our x minus 3. Okay, and then we have to do minus function g. Now function g is kind of this long function, this trinomial x squared minus 2x minus 3. Notice how I put these in parentheses, which I think will help you if you do that. Because this minus sign somehow has to apply to each term in this trinomial. Basically, you need to treat it like it's a -1 and you're distributing it. Okay, so if I multiply everything by -1, then I'm going to wind up with negative x squared plus 2x plus 3. That's the key. A lot of students do not wind up changing the -2 to a +2 and the -3 to a +3, and that's a common mistake. Meanwhile, I just bring down the x minus 3 and combine any like terms that we find. Like terms, this x is going to go with this 2x, and that'll be 3x. Meanwhile, this -3 and this +3, they're going to wind up canceling each other out. So what I have is I've got the negative x squared, which should go in the front. And then now x plus 2x, that's 3x. Now, like I said, -3 plus 3, that's 0, so we're not going to write that down. So this would be the final answer for number 3. Again, there's no denominator or anything, so we don't need to worry about domain restrictions. There are none. Now, number 4, this division, we've got this fraction. Let's set it up. P of x goes in the top, so that's x squared minus 9. Okay, so fine, x squared minus 9. Now over k of x, and k is x minus 3. Okay, so this is one form of the answer, but this can be simplified. But before we simplify this any further, it's time to talk about those domain restrictions. Now, again, you cannot divide by 0. So what value of x would cause the denominator to be 0? Because that's my domain restriction. Hopefully you see that x cannot be positive 3. Because if it were, I'd have 3 minus 3, and that would make 0, and you can't divide by 0. So that is my domain restriction. Now, I don't know if you remember this or not, but factoring. When you see something like x squared minus 9, there's a way to write that as something times something. Okay, you know what? Let's practice this off to the side for a second, because I'm not sure how long it's been since you have seen this before. Alright, here's a brief refresher. This is a pattern called the difference of two squares. Of course, it's called the difference because that means subtraction. And the two squares are, you see on the left we have x squared, so that's 1 square. But also on the right side, these are perfect squares because this is 4 times 4, and this is 6 times 6, and this is 9 times 9. So the way you can easily factor the difference of two squares is it always follows this pattern. Like you have x squared, so I'm going to have x and x. 16, as I mentioned, is 4 times 4. And it will work out if one of these is positive and one of these is negative. So x squared minus 16 is the same thing as doing x plus 4 times x minus 4. So take a guess how to factor x squared minus 36. And you should be able to say this very quickly and just say, oh, that's going to be x plus 6, x minus 6. Okay? Take a guess how to factor x squared minus 81. Hopefully you said that will be x plus 9, x minus 9. So that's the difference of two squares pattern. It comes up a lot. So if I wanted to, I could factor x squared minus 9 because this is the difference of two squares. Hopefully you were thinking, well, that's just going to be x plus 3, x minus 3. Now in this case, this will help us to simplify because we can now cancel out the x minus 3's. So a more simplified version of problem number 4 would be just x plus 3. But please note, even though we were able to cancel out the denominator, that does not get rid of the domain restriction. Still, x is not allowed to be 3. Okay, so that is how you do division. By the way, if there was nothing that could cancel out, you would have just left it like this. Alright, now, number 5 is back to what we were doing in the previous lesson, alright, the day 1 lesson. We are doing compositions. Composite functions, again, is where you're substituting one function into another. So, start with the first function, in this case, function b. I want you to just copy down the first function, but don't put any x's. Instead of x, put a parentheses. So when I see 2x minus 5, I'm going to write 2 parentheses minus 5. At that point, you go ahead and look back and try to see what should go inside the parentheses. And the thing that goes inside will be the other function. So p of x is what is going to be substituted in. P of x is 3 minus x. So I will go ahead and put in 3 minus x. Now I'm showing this in different colors to make it obvious, but I recommend that you do what I did and do this in 2 separate steps. First, write function b, leaving out the x and putting a parentheses. Then come back and substitute in the other function. That will help you avoid many mistakes. Alright, after that, hopefully it's clear that we're going to need the distributive property. So that would give us 6 minus 2x, and then just bring down your minus 5. These are like terms. Okay, 6 minus 5 is 1. So I'll bring down the negative 2x. Notice that minus sign doesn't go anywhere. So this will be negative 2x plus 1. That would be the final answer for that one. Let's look at part B. Same function at first is a function b. So once again, we will write 2 parentheses minus 5 like this. 2 parentheses minus 5. And then we look to the other function. Alright, function m is going to go inside of here. So that's going to be x squared plus 2. Fine. Once again, we will do the distributive property like, so that's going to give us 2x squared plus 4 minus 5. Okay, these are the like terms, so together they make negative 1. So we will have 2x squared minus 1. And that would be the final answer for part B. Looking at part C. Now these two problems are slightly different because we are substituting in actual numbers. So it's like a function inside of a function with a number. Here's how I recommend approaching these types of problems. I would recommend doing the inner function first. So in other words, I would start by just figuring out what is the value of p at 7. Just do this first, and then we'll look at the m part later. So p at 7. Of course, this just means substitute 7 into function p. So this becomes, because function p is 3 minus x, this becomes 3 minus 7, which of course is negative 4. Okay, so that's the value of p at 7. Now we can go ahead and do the other part. So that means what we really have is m at -4. In other words, you just go ahead and take this -4 and plug it in, because we just found out p at 7 is -4, so now I just put in the -4. So now I have to do m at -4. Well, function m is x squared plus 2. Okay, so that means this is going to become -4 squared plus 2. So that's going to be 16 plus 2. Positive 16, notice. So that's going to be 18. So 18 would be the final answer. Okay? So that's the easiest and cleanest way to do these problems. Let's practice that one more time. Again, let's start with the innermost function. And this is what we'll do when there is an actual number at which we are trying to evaluate. So let's go ahead and do b at -1 first. So let's see, here's function b is your 2x minus 5. So this is going to become 2 times -1 minus 5. Alright, so that'll be -2 minus 5, which is -7. Okay, now we will take that and substitute it in, because basically now we know that this is -7. Okay, that's what we just were evaluating. So that means what we really have is m at -7. Okay, we're basically taking this -7 and plugging it in to m. So function m, that's x squared plus 2. Alright, so because we're doing function m, we will be doing x squared plus 2. But we are evaluating at -7, so this will be -7 squared plus 2. So that's 49, positive 49 plus 2. So that's going to be 51. Okay, and that would be the final answer for part D. Alright, so that's a quick summary of the different kinds of problems. So we looked at how we can add, subtract, multiply, and divide, those basic function operations. We reviewed the difference of two squares. Don't forget about that. Don't forget that when you subtract, you have to distribute that minus sign and change these signs, so that's a common mistake. And don't forget that when you're dividing, if there are variables in the denominator, you're going to have to watch out for domain restrictions. The denominator cannot be 0. You cannot divide by 0. So if I have x minus 3, this cannot be 3. 3 minus 3 is 0. Alright, I hope this video has been helpful to you. If it has been, I really appreciate a like or a thumbs up. That's very helpful to me, and I will see you on the next video either way.